working together nicely. Everybody's happy. Glucose levels are good. Yay! Is that always the case? No. How do we know that glucose is not always at a happy level in the blood? What is the result? Usually, diabetes. Diabetes 1, diabetes 2, diabetes insipidus. What's the difference between them?
One doesn't register insulin, right?
Right, and it usually at a very early age it starts, and you're basically dependent on insulin shots, pumps, and so forth.
And then 2, your body can't produce insulin.
Or it's not producing it at a correct amount. And you may or may not be, it usually occurs later in life. And usually you can control it with diet. Sometimes you can't. Sometimes you might need to take insulin medication, and sometimes you might actually have to become insulin dependent. Diabetes 2.
I have a question. So with diabetes 1, can a person be born with it? Because my niece, she had diabetes and she's only 4.
It can be from birth, yes. Usually very severe. They usually have a lot of trouble keeping the glucose levels. They have to do a constant monitoring and so forth of the glucose levels when it happens that young. Yeah. What about insipidus? Ever heard of that one? That one happens, usually there's been some damage of some sort to the adrenal gland, for example. It could be damage from somewhere else in the body, but basically what happens is they're constantly thirsty. They go to the bathroom all the time. Your normal urine production should be about anywhere from 1 to 2 liters per day, depending on how much fluid you take in, and then what type of fluid did you take in, okay? Because some fluids are diuretics. Tea and coffee, for example. You can't count that as a daily fluid, all right? If you have your cup of coffee in the morning and you're supposed to do 64 ounces of water for the day, you can't count that 16-ounce cup of coffee as water. That's in addition to the 64. Now, under normal conditions, okay, 1 to 2 liters of urine production is normal. People who have diabetes insipidus can produce up to almost 20 liters per day of urine. They're barely out of the bathroom at all. It's usually the biggest indicator. But if they're put on the correct medication, it can usually be kept under control.
So, what type of damage would have to happen to the adrenal gland for insipidus to take place? Like someone stab you? Like that? Or just... Whoa. I don't know. Like get punctured, like in a car wreck or something?
Hold on. Your book doesn't talk about it?
It kind of lumped that in with the type 2 diabetes in the reading and in the videos for the homework.
Huh.
Because it talked about the type 2 diabetic actually producing a lot of urine.
Yeah, but see, insipidus is totally different. It's like, it puts diabetes 2 to shame, the urine production. I will look that up, Morgan.
You'll look at it.
Yeah. I used to know that answer, and for some reason it's escaping me right now. I'm sorry.
No, you're okay.
Because I know it's some kind of, I'm sorry, hold on, wait a minute. I knew it had an A in it. Okay? It's the antidiuretic hormone that's off balance. And so what'll happen is they can be given a, I guess it's like a, lab created antidiuretic hormone, and it usually takes care of the problem. And so they'll be on that usually for the rest of their life to help with the urine production. I knew it had an A in it.
Thank you.
There you go. Now, in your textbook, it's going to talk about other tissues of the body that produce hormones, and they're going to go on to do something within the body. Like, for example, it's going to mention atrionatriuretic peptide, which is the one that comes from the heart. That's one that you will probably hear a lot about because of it being associated to cardiac issues and heart attacks and so forth. But you have other parts of the body, the skin, the liver, the kidneys, the stomach, osseous tissue. You've got all these different tissues of the body, and in your textbook, table 17.5 shows you a list of all of that. Just kind of read through it. It's interesting. I'm not going to ask you about any of them because some of them we're going to come across as we continue studying into the other systems. So just kind of read over it because it's interesting. So this whole topic, this whole idea about hormones, this chemical, okay? This chemical that's getting produced, there are some characteristics of this chemical, of what we know or what we're going to term a hormone. The hormones are going to have a certain amount of stability. Some of them are going to last longer in the body, some of them not quite as long. So we term their stability based upon half-life. In other words, what is the length of time that it takes for that substance, half of that substance, to be eliminated from the circulatory system? That's a half-life. Some of these hormones, they're going to have a long half-life, some of them short. The ones that are going to have a long half-life, these are usually lipid soluble. They are traveling attached to that protein that I mentioned earlier, the globulin. The short-lived are usually water soluble.
Okay.
The short-lived, the water soluble, well, they're getting used rather rapidly, and so their release and their use is going to happen rather quickly. Another characteristic, these are chemicals that are used for communication. They are either going to communicate with itself, the cell that made it. You guys remember the autocrines? Okay? They're going to communicate with cells that might be within the same position or the same area. Y'all remember the paracrines and so forth? And then we're going to have the communication to other tissues way far away in the body. So they're all a form of communication. Their distribution, they are going to travel in the blood. All right? So they're going to be distributed in the blood fluid in some way. Either free, meaning they're unbound, or bound. If they're bound, it's termed reversibly because they can bind and then unbind and be used. So it's reversibly bound.
This is weird, but if someone gets a blood plasma transfusion or whatever, Can they uptake someone else's hormones?
Now, when we first began to do blood transfusions, it was very, very primitive. I mean, you would literally have the person on the table donating with a tube connected to the one accepting. All right? We have gotten very advanced now in blood collection and blood distribution. Blood is now broken up into 3 parts. So when you go give a liter of blood, they break it into the plasma portion, they break it into the factors portion, and they break it into the blood cell. Okay,
So
which
that's
we'll talk about more when we get into the next chapter. So now, like if you were to need just blood, you would only be getting the blood cells, the red blood cells, okay? But sometimes people have deficiencies, say for example in clotting factors, like someone who may have hemophilia, and they may need, like if something happens and they begin to bleed out, they can go now and just be given the clotting factors. And sometimes people just need the plasma. So we have learned, you know, that's why when you hear that radio commercial, and I think it's the guy from Itis, he's like saying, you know, give a pint of blood, I said a liter, a pint of blood, and you can save up to 3 lives. That's what he's talking about. He's talking about how we have now broken that down into the 3 components.
Is that what the centrifuge or whatever?
Yes. And if I'm not mistaken, some of that they can break down even further, but don't quote me on that, okay? So, when we talk about these hormones, okay, because they circulate in the blood, they do get distributed very quickly. It only takes about a minute for a drop of blood to make its way around the body as a whole, leaving the heart and its return to the heart. So that is rather quickly. And this chemical that's getting transferred, getting transported, what we're going to find is that their structure that they're going to have, if they're going to be lipid or if they're going to be water soluble, that is going to play a part on their effect at the cellular level. What you looking for, Morgan?
Oh, I was trying to put my
Oh.
back.
I thought maybe you were trying to see where I was at for the slides. Now, yeah, I gave the handout, so this should all be on the handout. Now, anything that's going to be a steroid hormone, that comes from cholesterol. Cholesterol is a fat. So therefore, anything that's going to be derived from the steroid is going to be lipid soluble. Now, lipid soluble means that those hormones, are going to move directly through the membrane. So this hormone is lipid soluble,